In the last video, we discussed about the structure of ovule, that is also called as the megasporangium, and the body of the ovule, it consists of the parenchymatous tissue, that is called the nucellus, and in the nucellus so many changes takes place, and ultimately that produces the female gametophyte. This female gametophyte is also called as embryo sac. So ovule is there, and internally it consists of embryo sac. Or in other words, you can say megasporangium is there, and internally it consists of female gametophyte. That means ovule and megasporangium both are equal. In the same way, the female gametophyte as well as the embryo sac both are equal. So the main structure that is present inside the ovule is the embryo sac. In the last videos we discussed regarding the development of the embryo sac, that means the development of the female gametophyte. And if you take the embryo sac, that is generally recorded as 7-celled and 8 nucleate. 7-celled and 8 nucleate. And in the embryo sac, it consists of 7 cells, but out of these 7 cells, only 2 cells they directly participate in the fertilization process. They directly participate in the fertilization. What are those 2 cells? One is called the egg, and second one is called as the secondary nucleus. One is called the egg, and second one is the secondary nucleus. Egg is also called as the female gamete. Egg is also called as the female gamete. So only 2 structures of the embryo sac they participate in the fertilization. One is called as the egg or female gamete, and second one is called the secondary nucleus. And if you compare both these structures, the egg is a haploid structure, and secondary nucleus is a diploid structure. Why it is diploid structure? Means it is formed by the union of 2 polar nuclei. That means each polar nucleus is a haploid structure, and because the 2 polar nuclei they are joined together and it produces the secondary nucleus, so the ploidy of the secondary nucleus is always diploid. So 2 cells of the embryo sac, one is a haploid, that is called the egg or female gamete, and another one is diploid, that is the secondary nucleus. Both these cells they directly participate in the fertilization process. So regarding all these points we already discussed in the last video. And in this video we will discuss regarding the types of ovules. So in the last videos we already discussed regarding the structure of the ovule. So suppose if you take a ovule, it consists of mainly 2 parts. One is called as the stalk of the ovule, that is called the funicle. With the help of this funicle, the ovule is attached to the placenta, a nutritive tissue that is present in the ovary of the carpel. So if you take a ovule, mainly it consists of 2 structures: basal stalk, that is called the funicle, and above the funicle it consists of a oval shaped structure that is called the body of the ovule. So in this way, if you take a ovule, it consists of only 2 structures. That is, one is funicle and second one is body of the ovule. And this part, that means the structure of this ovule, that can be compared with a globe. That can be compared with a globe. Generally, everybody has observed the globe. Generally, it is present in the schools. A globe means it consists of a stand, and above the stand it consists of a globular ball-like structure. On the surface, a map is there, world map is there. And if we compare the stand and the ball-like structure, which one is moving? Only that ball is moving. That means it is rotating 360 degrees. But what about the stand of the globe? That can't move. That can't move. In the same way, in this case also, if you take the ovule, the stalk of the ovule is called as the funicle. That is always fixed. That means it can't move. And on the stand, the body of the ovule, that means on the funicle, what is the structure? That is body of the ovule. The body of the ovule that rotates, just like that of a globe. So, the main criteria for the classification of the types of ovules is the degree of orientation of the body of the ovule on the funicle. That means the funicle is always fixed. On the funicle, the body of the ovule is rotating. So it is rotating in how many degrees? Whether it is 45 degrees, or it is 90 degrees, or it is 180 degrees, or 270 degrees, or 360 degrees. 360 means complete. That means one turn means that is equal to 360 degrees. So in how many degrees the body of the ovule that rotates on the funicle, that is the point that is taken into consideration to classify the ovules into different types. So what is the basic criteria? Depending upon the orientation of the, orientation means rotating. Depending upon the orientation of the body of the ovule on the funicle, the ovules, they are classified into some of the types. So that is the basic criteria. So based on that criteria, into how many types the ovules are classified. So that is the today's topic. So if you observe the different types of the ovules, the first type that is called as Orthotropous. That is called as Orthotropous. This Orthotropous ovule is also called as Atropous ovules. Orthotropous and Atropous both are equal. And the presence of orthotropous ovules is a primitive character, and that is found generally in case of gymnosperms. So in gymnosperms you can find the presence of the orthotropous ovule, that is also called as atropous ovule. So the presence of this type of ovule is a primitive character. That means in the early plants, if you observe the plants, they exhibit only this type of ovule. And in the advanced plants, different types of ovules they are present. But in the early group of plants like the gymnosperms, you can find the presence of this orthotropous ovule. So what is the meaning of this orthotropous ovule? So if you observe the orthotropous ovule, it appears like this. That means, see, this is the orthotropous ovule, and internally it consists of the embryo sac. Embryo sac is there. So here the funicle, that means the stalk of the ovule, that is always static. That means it can't move. And the body of the ovule, and if you observe this body of the ovule, how it appears like this, it appears in the straight fashion. So In this way, this orthotropous ovule is also called as the straight ovule. Is also called as a straight ovule. That means there are so many names for the orthotropous. That is also called as the atropous. Why it is called as atropous? We will explain now. And it is also called as the straight ovule. What is the meaning of straight? See, what is this structure? This opening that is present on the ovule, that is called the micropyle. This is the micropyle. And what is the opposite side? That is called as the chalaza. That is called the chalaza. This is the micropyle. And this is funicle. That is funicle. That means the stalk of the ovule. And if you observe this diagram, the micropyle, the chalaza, as well as the funicle, they are present in the straight line. That means on the same line, all these three structures, they fall. So that is the reason why this orthotropous ovule is also called as a straight ovule. So this micropyle, the chalaza and funicle, they lie on the same line. So that is called as the straight ovule, right? And why it is called as atropous ovule? Tropous means orientation. That means moving. So if you observe this body of the ovule that stands erect, that means it do not show any orientation. That means turning is totally absent, orientation is totally absent. That is the reason why this type of ovule is called as atropous. That means remaining all the types of ovules. In that case, the body of the ovule that rotates through some degrees. But in this case, rotation of the body of the ovule do not takes place. It stands in the vertical position. That is the reason why this type of ovule is called as atropous ovule. So A means absent, tropous means orientation. That means orientation is totally absent in this case. That is the reason why this type of ovule is called as atropous ovule. So this is the first category of the types of ovules. So the first one, that is called the orthotropous ovule. This is also called as atropous ovule or straight ovule. So the presence of orthotropous ovule is a primitive character. So that is generally found in case of gymnosperms. Generally, if you take gymnosperms and angiosperms, that means these two are the flowering plants. Only in these two groups of plants you can find the presence of the ovule. In other group of plants like algae, fungi, bryophytes, pteridophytes, in all these groups, generally all these four groups, they belong to cryptogams, non-flowering plants. So in non-flowering plants, you cannot come across with the ovules. So ovules are generally found whenever there are flowers. So there is a group flowering where flowering plants are present. They are called as the phanerogams. Phanerogams. So algae, fungi, bryophytes and pteridophytes, they are together called as the cryptogams. They are simply called as the non-flowering plants. So where flowers are absent, so ovules are also absent. But in case of flowering plants, they are technically called as the phanerogams. So phanerogams means they consist of gymnosperms and angiosperms. So gymnosperms are primitive and angiosperms are advanced. So only in these two groups of plants you can find the presence of ovules. So out of these two groups, gymnosperms and angiosperms are the primitive group. So it consists of this type of ovule called the straight ovule. So here orientation of the body of the ovule do not takes place. So it is called as atropous ovule. So here the micropyle, chalaza as well as funicle, all these three structures, they lie on the same line. So it is called as the straight ovule, and orientation is totally absent. So it is called as the atropous ovule. Presence of orthotropous ovule is a primitive character. So that is found in case of gymnosperms. So this is regarding the first type and the types of the ovules. So regarding the remaining different types of ovules, we will discuss in the next video. Thank you.